Stan Jabalisco back again with Capacitance Test Redux. I grew suspicious of the mutual capacitance between the test leads with which I connected this variable capacitor to my Radio Shack T-RMS digital multimeter to measure capacitance because it just seemed to me that when you're measuring capacitances that small with test leads that long and that tangled up, that you would probably have some additional capacitance introduced by those test leads. So I took the liberty of sacrificing a couple of my venerable clip leads, cutting them off, making them as short as I reasonably could, and then just stuffing them right into the contacts of the meter so that the meter's test leads and the clip leads are pretty much gone, and the only capacitance that's really going to contribute here now is this actual unit, a variable capacitor, a good one, from a parts source called Amplified Parts. Amplified Parts. Google on that as a phrase. You'll find a lot of really cool electronic components there. This digital multimeter you can get at Radio Shack for about 70 bucks. It's set now to measure nanofarads, and if you look very closely you'll see it says 0.438 nanofarads, which translates to 438 picofarads. So, and this is rated, I believe, most of these variable capacitors used to be 365 picofarads or so they said, and the minimum capacitance somewhere around 10 or 5 picofarads. Well, when I measured it before, you can watch that video just a little earlier today, the video called Capacitance Test. Well, this is Capacitance Test Redux, or Capacitance Test Refined. You'll notice that the maximum capacitance appears to be a bit less. When I bring my hand near all of this stuff, the change is considerably less than it was when I had those long test leads in there. So let's change the value of this capacitor now by, it's fully meshed right now. Let's set it for half. It was 438, now it's 217. That's just about exactly half of the capacitance. That surprises me a little bit. I didn't think that would be that it would be quite linear like that. But let's now take it all the way down so that it's not meshed at all, and it shows zero picofarads. There is, for all intents and purposes, no capacitance here at all. I might as well just unclip these clip leads. Bring my body near it. Very little effect, which is kind of reassuring to me for my future radio frequency circuit design plans. So this is a little bit better test, and it'll give us definitely a truer indication of what these actual capacitance values in this capacitor are. Particularly seeing as all the way open it says 0. There can't be any stray capacitance here worth bothering about, can there? There's none at all under test. So that's kind of neat. I'm glad that I did these tests. I learned something today. Maybe you did too. Stan Jabalisco signing off. Until next time, so long.